Hi everyone, welcome back to BIMKLUE Revit tutorial. So from what we have learned from the last session, we will be able to complete all the piping inside this house here. This is the completed piping inside the house. So we have cold water and we have sanitary piping that connecting the level 1 toilets, go down following the stack and go down to the ground floor. And this is the discharge, most likely discharge to the external sewerage manhole. Yeah, so normally each of the residential houses will have their own sewerage manhole or septic tank. This is for modern building design. Yeah, okay. So for cold water and hot water, we basically copy and paste the whole concept of the toilet piping connection, then paste to the ground floor and paste to the master bedroom's toilet as well. So this is what we have here. So remember, keep the gradient flowing down and keep all the piping above the ceiling level. If you don't have enough ceiling level, then you will need to talk to architect to lower down the ceiling level. Okay, this is what we have here. Then go to the ground floor here, increase the view range to about 4,000, let's say. Then don't forget to also branch a pipe to your kitchen. This is your kitchen here. And then of course your courtyard, you can branch a pipe to wash your car here, okay, or do some irrigation works over here. Okay, so this is up to your design. Then before we continue, we talk a little bit different here this week. So based on the last comment of one of the followers, he want to learn something like profiles and basically modeling of drainage. Okay, so what we have here, I will model two sumps here and with a parametric drain that you can adjust the inlet level that you want. Okay, so first of all, two sumps. Okay, so the sum. Then normally I would use the generic model. Okay, come to here, we start with a generic model. Okay, always generic model. Then first thing first, model a few reference plane, regardless what other dimensions is. Okay, so next, okay, we do dimension this first and another one dimension, don't lock it. Okay, so the second one equal and this one don't lock it. Okay, so then we will assign a parameter on this, some width and some length. Okay, so remember to put it as instant parameters. Okay, then this is the sum length here. Okay, instant. Okay, then next we will create the sum base. The first thing is the base. Okay, so this is the base. Then we lock 4 sides of your square or rectangle. Okay, then so when you change the diameter, the dimension of it, then the base will change accordingly. Okay, so this is what we want. Next, I will create the front elevation. So you know this is the depth of the sum. So the extrusion, make it, since it's the base, make it at the bottom. So let's say the base will be 200 thick. Okay, then your sum wall. Okay, to create the wall, normally I will use extrusion. Just use extrusion and then lock the 4 sides of your walls to here. Then offset, let's say the wall is 150 mm, so just offset the wall inside. Then you trim the lines and then make sure your thickness is 150 by locking the dimensions of 4 sides. Okay, 4 sides of the wall. Okay, finish that, then try to adjust the dimension of your sum, so the wall is just adjusted accordingly. Okay, next will be on the front. Then last thing you need to do is create a reference plane for your height of the sum. So create another parameter for this height of sum, or height of the sum is up to you. Yeah, okay, so attach to the top. Okay, the grating, just extrusion will do. Okay, so next, assign the material on this, let's say the brick sum wall. Yeah, then the base of sum, type is also okay. Okay, then we have the material done, then we can load inside to our project. Okay, just save as a drain sum. So just save it, then place somewhere here. Okay, then adjust the discipline to coordination, so you can select the sum. Okay, then you can adjust the sum dimension here, or just key in over here, because this is the instant parameters. Okay, just set it at 1 meter dimension. So this is the drain sum. We will do it from here to behind. Yeah, okay, just draw 2 sum, and then cut a dimension, cut a section over here. Let's see from here. Okay, we have 2 sum here. Then if you gray out, you need to check the properties here, change the discipline to coordination, so you can select your whatever model that it's been locked. Yeah? So make sure it's under the ground level. So adjust the sum level. Let's say this one is deeper than this one, so the height of the sum automatically you set it at 1 meter. So move this down here. So how to check the inward level? So IL is inward level, so but EL is the checking the spot elevation of your families over here. Any points? Okay, here like this. If you want the prefix of IL, then you can key in here IL. Then you have the IL here. Okay, or key in IL here. Then you have IL in front. So this is how you do it inward level from the section view. Okay. Then if you want to do it from the plan view, of course you can still EL is a shortcut key. If you don't know the shortcut key, never mind, go to the annotate. Then you will see the spot elevation over here. Click on here. Then you can spot the elevation below here. Okay, so make sure your view range is covered, enough to cover whatever you want to view. Yeah, so it's like this. Okay, EL again. Okay, it can't snap at the bottom, so doesn't matter. Or normally what I make it to snap to the bottom is did the parameter, did the family, I put a little squareness over here, just a little square like this. Then make sure it's at the bottom. Okay, then load it back to our project. Now you can see the square here. Then you can EL again, then you can snap the inward level. Okay, or you can draw a line. It's up to you to how to manage your family. Okay, just for ease of drafting purpose. So now the drain. You can use a slab to draw the drain. Of course, use the floor to draw the drain base. Yeah. Let's say like this. Then you can slope the arrow from here up to here. This is a slope. Okay. Then before you finish that, let's say it's 300. So just let it be 300. So we go to the section view. Then you adjust your slab here. Okay. Looks like 300 is a little bit more. So need to lower down by 189.8. You can see from here. Okay. Then you can go to the reference plane and edit your slope again by minus. Okay. Then go to the view. Now you can have the slope slab. Yeah. Then the next thing is you can draw the wall here. Oh, this troublesome. Close it. This also no use. Close it. Go to the ground floor. Then you can draw a wall here. Okay. You can draw a basic wall. Let's say it's a 900 brick wall. Then just draw a wall over here. Okay, let's say it's exterior. Just draw a wall here. Okay. So what's next? Go to here. Of course, is you go to the view. Then you adjust the profile of your wall. Let's say like this. Up to here. Then edit the profile. Then snap, align it. Unlock it first, then align it to the bottom like this. Okay. Then finish here, then you will mirror it to the other side or copy it to the other side like this. So turn it to 3D views. Down your drain with a gradient is ready. Just a few steps you can complete your drain. Okay. So of course the cover, you can use the normal extrusion techniques to complete your drain cover. Then next one, if I have a big scale project and then my drain is curved here and there, then it's kind of waste of my time to draw the profile of the drain by using the slab and your wall. Yeah. Let's say I have a family that I can adjust the drain invert level as I require. Yeah, okay. So how do we accomplish that? We go to New, Family. Okay. We can start with a generic model again. We create something simpler. Let's say I have a drain length. Yeah, I want to change this length. Okay, just give a dimension here. So this is the length of my drain. So instant. Okay. So next we go to the left view. We start with the left view here. Okay. So we create something so-called the width of the drain first. Okay, we can create two reference plane here. Then we give a dimension here. Then equal it. Then this is the width of the drain. So just give a parameter that. Okay, instant. Okay, next I'm going to use something like a blend. Okay, use the blend tool to create the extrusion. Let's say the first thing is I edit the here. This is my first base. Let's say I fix my base to 200. Okay, just 200. at the top, let's say another drain base is somewhere here, which is also 200. Let's make it 200. Okay, something like this. So I finished that. Okay, so from the front view here, so okay, I created something like this. Then I make sure this one snap to that one end here, and this snap to the other end here. Okay, so it's basically the slope drain like what we have created just now, the base over here. Okay, just for this case we control it by using parameters. Okay, then from here, how to limit the width of your blend here. Okay, so we go back to the left side. Make sure you create another reference plane that you need to specify what is the second height of your drain, which is another profile. Yeah, the tilt height of your drain. Tilt. Okay, use this as instant. Okay, then next one, edit back your base. Let's say I want to constrain my drainage width with the parameters that we have created. Okay, just lock it. So this is the first profile, so I don't disturb it. Then finish that. So the second profile at the top. Yeah, so next one, make sure this is snapped to the top of your this tilt drain parameter. Okay, then snap to the width of your drain. Okay, of course the thickness is 200. You want to maintain it to be 200, so key in 200, then lock this to 200. Just lock it. Finish that. Then you can start to test your drain. Let's say the drain length like this. Okay, we'll move accordingly. So the drain width is like this. Okay, you can move accordingly. Then the tilt. Okay, let's go to the front, test the tilt angle. Let's say the tilt drain is 300. Apply. Okay, the tilt is slower down. So this is how you control the height of your drain. So next one is the here, yeah, the front here, left here. Go back to the left. So now is the wall of your drain. Now you need to create the wall of your drain, top of the drain. Yeah, so create go to create a reference plane. This is a reference plane indicated the top of your drain compared to the first profile. Let's say this is the top of your drain. Instant also. So next, you need to create the wall of your drain. So just also using the blend method, you can create this one. The first profile. Of course, locking this to here. Let's say the wall thickness is 150. Okay, I'm going to just fix the wall to 150. Of course, if you want more advanced, to create another parameters on this here. Just lock it. Then this one, just lock it over here. Then the base, just lock it here. Then the top, just lock it here. Okay. Then finish that at the top. The second profile will be following the tilt of the drain, which is the second profile behind. Okay. So similarly, lock the wall, base of the wall, top of the wall, and the thickness is 150. just dimension it 150, then lock it. Okay, so what's the outcome? Finish that. So from the front view, you see the wall is like this. So lock this to here, lock this to here. Okay, we're going to finish that soon. So this is the drain, yeah? So the first wall. So let's adjust this. Let's say the length will be 5 meters. Okay, the drain following. Okay, then the drain with the tilt angle of the drain, let's say it's 500. Okay, it's following. It's worked pretty well. Then the next one will be the width of the drain. Let's say, go into the 3D view. Let's say the drain width is only 400. Okay, it's like this. Okay, everything is nice. Adjust to width is 1005. Let's see. Okay, nice. Then next one, mirror this to the other side. Finish that. Look, copy. Click on here, copy, mirror to the other side. Okay. So let's try this out without locking anything. Yeah. Let's try this out. Let's say 3 meters. Okay, this is not locked, so it don't work accordingly. So we need to repeat same steps like just now. Okay, so go to my front side. Okay, I have to lock this over here, lock it, lock this over here, lock it. Okay, go back to the 3D view. It's like this. Let's see. Tilt of the drain, change it to 300. Okay, this work nice. Top of the drain, change to 1002. Okay, work well. Okay, width of the drain is 1000. Okay, everything's well. Then assign the parameters on the material. Drain wall. Instant. The drain base. Instant. Okay. Done. Then load it to your project. This is parametric drain. Very fast, yeah? You see, I'm going to use just a few minutes to complete this task. Okay, place it somewhere here. Let's say I want to match these two sum. What should I do? Okay, 90 degrees like this. Okay, let's say I want to place to here. Okay, we just reduce the width. Okay, in this case very easy now, because in a big scale project you will face a lot of different width of the drain, so it's good to create a parametric family to handle this kind of situation. So let's say 800. Okay, for small houses maybe it's just a 600 to maximum already, I think. Okay, just move this to here. I'm gonna create another two sum. Okay, just copy this to here, then just align to the middle sum. Okay, so just cut this here. Okay, top the drain, this. Okay, okay, this is invert, so just mirror this, doesn't matter. Okay, so just drag this over here, drag this over here. Okay, you see this, then this is the difference, then just measure this 200 difference, so the tilt reduce 200, which is 100 now. So move this up, then the wall, top of the wall, reduce 210. 210, 990. Okay, so this is what we have. Then this can be repeated anywhere. Of course, change it to coordination first. So you can select your drain. Okay, assign the parameters here. Drain base is concrete. Drain wall will be brick. Okay, that's exactly the same. When doing the quantity extraction, you can extract the material quantity instead of the wall quantity and the slab quantity to gain back your quantity. Okay, so of course you need, in order to be more specific, you need to name this material as drain wall and the slab to be drain slab, to be more specific, or else it will mix around with other elements of the slab. Then you can't identify which slab is for the drain, which wall is for the drain wall. Yeah, this is what we have learned this week. Okay, basically it's how to effectively control your parameters and use of parameters to create more elements that flex to ease your work. Yeah, okay, that's all for this session. Thanks for joining.